Good morning, everyone. I hope that you are up and ready to start another math lesson today. Today, we're going to be looking at lesson 1-5. In class on Thursday, we did 1-4, and you had begun to do your problems for that lesson. Let's see where I put that. Here it is. Okay. This is what we did on Thursday, and you have problems to finish on the back. I did collect these from you on Thursday just to see how you were doing, and I handed them all back to you before you left school on Thursday, so you might want to take a look there and see what I circled and see what you need to fix. Also, there is a video posted on Google Classroom showing you the steps to each and every problem, so please feel free to watch the video and find the problem or problems that you need a little assistance with and use that as a guide to get through some of the harder problems. Hopefully you were able to solve some of the more simple ones and before we move on to lesson 1-5. But let's go ahead now and start 1-5. So the title of it is Solving Inequalities in One Variable. So what you're going to be able to do by the end of this, the objective is that you'll be able to solve and graph inequalities. So the first question is what is an inequality? Equals means we're equal. Inequality is everything but that. It could be something, a number that is greater than a number. It could be the less than sign. Okay, it could also be a greater than or equal sign or a less than or equal sign. And we saw all of those signs last year. We dealt with inequalities already. So this is going to be a little bit of a refresher. However, the algebra problems are a little tougher this year. So let's look at this first problem. Now my board is not wide, so it's hard for me to write notes, but I do want to write some notes out to the side here. So when you look at this problem, I'm thinking, first of all, what is the first thing I need to do and what terms do I have that I can combine? Well, I notice here that I have some x terms that I would like to be able to combine, but my 3x is part of a bigger quantity. It is 3x minus 1 and it's inside those parentheses. So the only way that I can successfully combine 3x and 6x is to get that 3x outside of the parentheses. So how do I do that? Hopefully you're thinking to yourself, well, we're going to distribute. So off to the right here, please write the word distribute. Oops, I gotta squeeze it in. I would have negative 12x. Now here's where some of you get a little bit loopy. So I want you to think about this. I have a negative 4 and I'm multiplying it with this 1 in here, but it's not just 1. Remember I told you that you have to start thinking about the signs that are to the left of each term. In this case, the term is a 1. And you attach it to that. So really this isn't just 1, it's a negative 1. Because remember, when we think subtraction of a number, we're also thinking that it's going in a negative direction. So that minus sign acts as a negative sign as well. So when I distribute this negative 4, I'm distributing it with this negative 1. So negative 4 times negative 1, a negative times a negative, is a positive. So now I have negative 12x plus 4 plus this 6x is greater than or equal to 16. Okay, the next step that we want to do, there's two ways to do this. I could combine my x terms here and then move my 4, but I'm going to go ahead and subtract the 4 from both sides first. And what we're actually doing here is subtracting 4. So please write that out here, subtract 4. So let's go ahead and do that. So I subtracted 4 because over here it was being added and I'm trying to undo that addition of 4 by subtracting it with the inverse operation is what I'm doing. And what is left is negative 12x plus 6x is greater than or equal to 16 minus 4, which is 12. The next thing that we're going to do is now I can combine my x terms here. So off to the side, let's right here combine x terms, or actually rather than writing x terms, let's change that a little bit. Let's say combine like terms. In this case, it actually is an x term that these x terms are what we're trying to combine, but let's just write it as combining like terms. So I would have a negative 6x is greater than or equal to 12. Now I am going to divide by a negative 6. Now this is really important here, and I'm going to have you make a special note on your notes in just a minute. I am going to divide this. Remember, I'm trying to isolate x. I want x to be all alone. Okay, that negative 6x needs to go away, or the negative 6 needs to go away. So I need to divide this not just by 6, but by negative 6, because negative 6 divided by negative 6 is 1. Okay, so now I have this on both sides. Now, here's where I want you to pay attention. I'm going to have you write a note or two off to the right-hand side. We are going to divide this, so I would have x here, and I would have negative 2 here. But because I divided by a negative, I have to flip my inequality sign. Only when I either divide by or multiply by a negative, when I have an inequality, I have to flip it. Okay, so let's put a little note out to the side here that says, I'll put it down here. Let's see if you can still see where I'm writing. Yes, you can. Okay, on your notes, you can write it off to the side there. But you want to say flip inequality sign when you divide or multiply by a negative number. Because if you think about that, I had a positive number over here, okay? But when I divide by a negative, it changes it to a negative. Okay, so it's no longer positive, so it makes sense that that sign has to flip around. So please make sure that you have that written there. The last thing we're going to do to this problem, and I'm going to turn this around, is we're going to graph x is less than or equal to negative 2. X is less than or equal to negative 2, and we are going to graph that. So on your notes, I gave you the number line, but let's go ahead and fill this in. We'll put 0. It doesn't have to be perfect, but something like this. Now, we talked about this last year also. We spent some time last year, quite a bit of time actually, graphing inequalities. I'm going to graph at negative 2. So I'm going to find negative 2, and I'm going to draw a circle. It's less than 2, negative 2. But it can also be equal to negative 2. Therefore, we darken in our circle and make a solid circle. So what that means is that in this inequality, x can be a number that is either less than 2 or it can be equal to 2. Okay, so either one of those, both of those suggest that we have to include 2. Okay, so it could be less than 2, which is what this arrow stands for, or it can be equal to 2. If it did not have the equal sign on there, then we would have left that an open circle. But because it does, we want to make sure we indicate on our graph that we actually mark that point at negative 2 so that we are sure to include it as part of the solution there. All right, that is number 1. Number 2, example. We're going to solve an inequality with variables on both sides. So we have 2, and we have 3.5x plus 19 is greater than or equal to 1.5x minus 7. Okay, so let's work through this one. So I want to try to collect my like terms. So I'm going to write on this side right here, collect like terms. Oops. That's the first thing that we want to do here, collect like terms. So I notice I have x terms on both sides of the equation, or my inequality rather, and I have constants or whole numbers on both sides of the, or integers I should say, because we're going to look at this as a negative 7. Okay, so let's collect like terms. So the first thing I'm going to do is try to get my x's together. So I'm going to pull this 1.5x to this side by subtracting it, because notice it's positive up here. So in order to get rid of it, I'd have to subtract it off there. And remember, the golden rule of algebra says whatever I do on that side of the equation, I also must do on that side of the equation. So that's what I've done, and this zeroes out. So on this side, I'm left with a negative 7. And on this side, I'm going to have 2.0x, or just 2x plus 19. Okay, so I collected the like terms by, what I did was I subtracted 1.5x, and then I'm also going to subtract 19. Okay, because I want to get that pulled over to this other side. So let's subtract 19 off. And I'm left with 2x is greater than or equal to a negative 26. Now I can divide by 2. I'm trying to isolate x. It's a positive 2, so I don't have to flip my inequality sign. Okay, my answer is a negative, but remember, only if I divide by a negative do I flip my sign, because when I divide by a negative, it's going to change my sign over there. Think about it. If I had divided by a negative 2, then my answer becomes positive, and that's why I have to flip my sign around. But in this case, it's already negative, and when I divided by a positive, it stayed negative, so I don't have to flip my sign around. So the answer to that one is x is greater than or equal to negative 13. So let's graph that. I'm just going to put a 0 here and a negative 13 here, and we can just imagine that negative 1, negative 2, negative 3, all the way down to negative 13 is in between here. And I'm saying that x is at 13, but look, so it can be greater than 13. So we know it's going to go this way when I color it in, my line. X can be greater than 13, but the equal sign indicates that we want to include negative 13. So it can be greater than or equal to negative 13. So the solution for this inequality can be any number that is greater than 13 or equal to 13. Make sure that you solid color your negative 13 spot on your number line. And that's the example for number 2. If you need to pause the video at any time to catch my notes, please, please, please feel free to do so. You can always come back in and finish it up. All right. The third example, there's 2 there. We want to understand inequalities with infinitely many or no solutions. What in the world does that mean? Well, let's take a look. So example A has a negative 3, 2x, and I challenge you right now to see if you can work this out. Maybe you want to pause the video for just a moment and see what you get for your solution for x. Okay, and then come back and see, because you're probably going to look at it and go, what did I do wrong? And good chances are that you didn't do anything wrong. So the first thing I'm going to do is I'm going to distribute my negative 3 times a positive 2x. I would get a negative 6x. And my negative 3 is being distributed to a negative, look, 5, which would give me a positive 15, is greater than negative 6x plus 9. Okay, the next step that we want to do is I'm going to try to get my x terms together. So I'm going to add a 6x to both sides. Ooh, I wonder if you can see what's happening already. Aha, it crosses those both out. And I end up with 15 is greater than 9. Is that true? Yes, Mrs. Quigley, that is a true statement. So please write true beside that. And what this means, when you end up with something like this, where your x's go away, but you come out with a statement that ends up true, like this one, 15 is greater than 9, then that means that there are multiple solutions that can fulfill this inequality for x. If I put x in, any number in for x, it makes a true inequality. So let's write this. So it's true. Therefore, x can be any value. Okay, so keep that in mind. If you come up with some funkiness like this where the x just disappeared, but it makes a true statement at the end, then you know that I can pick any number out of thin air and plug it in for x, and it would make my inequality true. Okay, the next one is going to show us something different as an outcome. So let's look at letter B's example. Letter B gives us 4x minus 5 is less than 2 times 2x minus 3. All right, so on this side, I'm just going to leave this one alone for just a moment, and I'm going to come over to this side and do my distributing because I need to get that x out of the parentheses. So I would have 4x, and I'm multiplying 2 with a negative 3. Remember, the negative attaches himself to the 3. So it's 2 times a negative 3, which is minus 6. I'm going to get my x terms together, look, looks like we're heading in the same direction as we did on the last problem. But look what happens. -5 is less than -6. Is that a true statement? If you think about that on a number line, you have 0 all the way down to -6. -1, -2, -3, -4, -5, -6. Oh, goodness. Well, -5 is actually greater than -6, isn't it? But my inequality shows that -5 is less than -6. So is that a true statement? I think not. So off to the right, we're going to write false. And let me talk to you a little bit about what that means. So this is a false statement. So what that means, therefore, there are no solutions or no solutions for x. It doesn't matter what I choose to put in for x. I can try all day long. I can pick a positive number. I can pick a negative number. I can pick a fraction. I can pick a decimal and put it in there. But at no time will it make a true statement. So when you come up with something that is false, that means there are no solutions for x in that inequality. Okay, so it's kind of nice to see how that works out. All right, the last one is going to be one of those complicated word problems, but we're going to work through it together. When you get your final test, where did I see this? I don't remember if it's on the test. Somewhere along the line, I'm going to see this problem come up again, and I will let you know if you need to do it. Okay, but let's go ahead and at least get the notes on so everyone is exposed to the problem. If it shows up on a test later, it would be for our honors students to solve for the answer for that. And if you are just taking algebra as a regular algebra student, then you can try the problem for a bonus problem, but honors kids will have to do it. Okay, so in your book, let's read this. I did not type out the whole problem because I did not want to run out of room. So turn in your books with me to page 32, where you see the blue roses and the red roses. It looks like this. And when you get there, take a look at it. It says Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? And at what point will it be less expensive to order from florist B? Now, we solved some problems like this recently, but they were not with an inequality, but they were rather with just equations where both sides were equal. I'm going to get a couple colors over here because I'm going to use a few different colors. Okay, so we're going to set this up. Here's what we're going to look at it this way. So at what point is the cost of blue roses less than, and actually I'm going to write words here first because that's what's on your notes. And then in red, the cost of red roses. Okay, so we need to come up with some expressions that will meet this. So let's think about this. The cost of the blue roses, we know that each rose is, according to the book, it shows that Florist A's roses are $4.75 per blue rose, plus you have to pay $40 on top of that for a delivery fee. So we're trying to figure out at what point are they, you got to think of it this way. At what point do we reach a number where the prices would be equal? Okay, and then I want to figure out from there, I have to figure out at what point, though, is it less expensive to order from which florist? So we're going to look at florist A first and see at what point does, are the roses going to be less expensive? How many do I have to order to make my final price less expensive than the red roses? So let's make an expression for the blue roses. We're told that it's $4.75 per rose. We don't know how many roses we're going to order. That's what we're trying to figure out. How many do I need to order to keep florist A? We're going to call this one florist A. And we'll call the red roses florist B. I'm going to write that up top here. Okay, and you might want to write that on top of your notes there. Okay, so $4.75 per rose, plus there's also a $40 delivery fee just to take the flowers to the place that you're having them sent. Here's my less than sign in green. And then finally, let's come up with an expression for the cost of my red roses. Okay, those are $5.15 per red rose, times however many roses, we're not sure yet. Plus, this one's going to charge a $25 delivery fee. So you might think, oh, this is going to be the best way to go because I only have to pay $25. But that might not really be true because the roses are less expensive over here. So see, the combinations, you have to really work this out to figure out at what point are the roses going to be less expensive if I go this route. So let's figure out what that number is. Let me get my black marker here. And we're going to do a little solving here. So the first thing I'm going to do is I'm going to get my X's together. I'm going to move this one over here and here. Okay, so we're going to cross this one out, and I have 40 is less than, and when I do the math on this one, I end up with 0.40x plus 25. Okay. Now the reason, oh yes, I did explain that. The reason we have the less than sign here is because I'm trying to figure out when florist A will be less than florist B. Now could I have moved 515 over here? I could have, but in my mind I'm thinking, well, that's going to give me a negative dollar amount over here, so it doesn't really make sense for me to move it to that side. But I could, because at the end it will turn out to be the same. But just for the sake of keeping our numbers positive, let's move the $4.75 to this side so that when I subtract it, I end up with a positive 40 cents X. Now I'm going to subtract 25 from this side because I'm trying to collect like terms, and I'm going to subtract 25 from this side. So now I have, this is my new line. So 15 is less than 0.40x. Let's do the division because what we're trying to do is isolate x. So we'll divide both sides by 0.40, and I end up with x is over here is less than, and when you stick this in your calculator, you're going to get a really weird number here. I say weird because remember, x determines, or X is representing the number of roses. Well, I'm not going to order 37.5 roses, right? But think about this. So at 37.5 roses, if I had them cut it, at 37.5 roses, they would be the same. It wouldn't matter which way I go. But if Derek plans to buy 38 or more roses, so if he buys more than 37, we'll say, okay, 38 or more, it's going to cost less to go with florist A. Okay, if I order 37 or less, so less than this number is going to mean that florist B is the better way to go. So what I would like for you to write at the bottom there, and I'm going to show you where I wrote mine. Right down here across the bottom, I'm going to have you write out what the findings actually are. I'm going to erase this problem. And I want you to write this across the bottom. There's two statements in words that I'd like you to write. The first one is, so if Derek plans to buy 38 or more roses, then florist A is less expensive. Okay? But if he plans to buy 37 or less roses, then florist B is less expensive. So you see, really the trick is, which is more expensive and when? At what point? can I order so many roses that my price is going to be better with one florist over the other. And so those findings, when we came up with 37.5 roses is less than X, that's saying, because remember, florist A was on this side and B was on this side. Okay, I know this is a little bit complicated, but just try to think through that, what that means. Please make sure you have these written, because that is really the final answer for the problem. So you want to know at what point is it less expensive to go with florist A, and at what point is it less expensive to go with florist B? Because the roses cost different, and there's also a different delivery fee. So the fact that one last thing, the fact that blue roses are less, but their delivery fee is higher, and the fact that florist B's roses cost more per rose, but their delivery fee is less, you really have to do a little figuring. It's not easy to just go, now if this was $25 and their roses were $4.75, then it's kind of a no-brainer, right? If the roses are less and the delivery fee is less, then yes, florist A every time is going to be the right choice. It just depends how many you're going to get. Now, really and truly, in a real world, you're probably not sending somebody 37 or 38 roses. But you never know. On Mother's Day, you might be sending those to many women. Mother, grandmother, aunt, best friend. I don't know. All kinds of thoughts go through my mind. So it's best to just figure out at what point florist A is a better deal than florist B, and that's how you would work that out. So now you've been exposed to that problem. Please make sure that you have all that you need written down. You can go ahead and finish up the rest of this work on the back side. Everyone have a great weekend, and please don't forget to check out the video where you're going to find the answers done for you for today's lesson, which was 1-4. Have a wonderful weekend, guys. Thanks for watching. See you next week. Bye-bye.